Okay, so I'm going to go through doing one sample chi-square for standard deviation or one sample chi-square for variance. And I know it's a one sample chi-square for either one. I'm going to say standard deviation probably from now on, because it says right here, find 98% confidence interval estimate for the standard deviation. Well, the only thing that we have that does that is a one sample chi-square. So they give me some summary stats. I have 12 subjects, mean of 97.8, which we don't care about, and a standard deviation of 41.1. The standard deviation is from these 12 subjects, so that means it's 8 sample standard deviation. That's important. So I'm going to go stat, I'm going to go to variance, I'm going to go one sample. So if I'm doing a one sample chi-square, you have to go to variance, one sample, in this case with summary. And bring this up. And the first thing it asks for is a sample variance. It told me the sample standard deviation. So to get the sample variance, if I could run my calculator, I got to square that, and I get 1689.21, and I'm going to put that all in there. 1689.21. Don't round this, unless it's a really long decimal. You don't want to be rounding these. Sample size is 12. Mean, irrelevant. It's not needed for this test. Changes to a 98. Compute. And I'm seeing my lower limit is 751, my upper limit is 6,085, which definitely aren't these numbers. But you'll notice right here, they want a confidence interval for sigma. That's the standard deviation. And you'll notice right there, this is for the variance. So I got to take the square roots of both those numbers. Square root of 751.52001, and yes, I'm putting the entire decimal in. Sometimes it'll make a difference when you round on this. Will give me 27.41. Then square root of 6085.2814 gives me 78.01 when I round. Now, next question, looking at this problem, do the results indicate whether the treatment is effective? This is irrelevant. Finding a standard deviation is irrelevant if the treatment is effective. I mean, the mean would be what you'd want to look at for wakefulness, not the standard deviation of the mean. So no, the confidence interval does not indicate an effective treatment. Now if I go to another one, here's another one. And I don't care about the chi-square icon. It says, use sample data to construct a 90% confidence estimate of sigma for the standard deviation of the duration of game times played. All right, so I'm going to take this and copy it to the clipboard, probably the easiest. And do a little Control C there. Come over here. And get Control V. I should remember that. There we go. Make sure I got them. 38046. Okay, looks like I got them all. Close this. All right, again, I'm doing one sample chi-square. Stat. Variance. One sample. This time with data. Gotta move this over so I can see a little more. Gotta tell it where it's at. Well, the only data I have is in var3. Click on this. Change it to 90. That's what they wanted. Hit compute. And I got some ginormous numbers here, but again, I bet if I take the square root of these, I'll come up with those numbers. So square root of 49580.555 gives me 222.666, which rounds to that. And the square root of 213.233.68 gives me the other number. Okay? All right, so one sample chi-square.